Okay, so what I was just saying is, so today I want to talk, I want to start out talking about memory usage. And then what I want to do is, I will probably start a little bit on IO. And for the IO stuff, I don't have a PowerPoint. What I'm going to do is I'm actually, we'll do some demonstrations in idle, and I'll show you some things about how the IO works in Python. And then we can talk about, for instance, the homework question that was just raised. So here's where we're at, right? It's Thursday. This is Thursday of, and I'm consulting my calendar here. This is April 9th. This is Thursday of week 10. We have 4 weeks of classes left. And as I showed you, I had a PowerPoint I showed you just a little while ago, and let me open that up because I had actually just closed it, which I realized I didn't necessarily want to do. So let me share that. And it is that one. Okay, so this is the kind of the roadmap for the rest of the semester here, right? This is what we're looking at, is memory usage today, and then we're going to get a jump start on IO a little bit, but sets and dictionaries and this memory usage thing. Now I want you to understand, you're not going to get quizzed next week on the memory usage. The memory usage is for you to understand how Python works. It's not something where I actually expect you to do this in the quiz. Okay, and I promised you that by sometime this weekend I'd have a better feel for you on what this super quiz, as I'm calling it, will look like next week. But at this point, what I'm talking about here is it's going to be a Moodle quiz and a VPL exercise. You're going to have 24 hours to do it because people are in different time zones. They're on different continents. So also, I recognize some of you are working, some of you have bad internet. There's a lot of stuff going on. So email me individually if you have extenuating circumstances and you need an extension for that. And I will be very liberal in doing that. Okay. So that's next week. That replaces class. Okay. Generally speaking, we don't do like here at SUNY. It's weird to call it here at SUNY when I'm sitting in my den, but we don't do evening tests. But there are classes that have common exam times where they might do an exam for a bunch of sections all at the same time. When I went to college at a large Big Ten university, we often had evening exams. And when we had an evening exam, there was no class that day because it basically wasn't fair to say, you have to come to class and you have to come tonight and take a 2-hour exam. So next Thursday, we won't have class. That does not mean I won't be in Zoom. I will be here for class, but it'll primarily be an office hours session or to answer questions about that quiz. Okay. So then the week after that, we're going to get into objects. Basically, classes and objects is really the biggest thing we have left to do, and it's important and it's big and it's a little complicated. Okay. And then depending on how that goes, we'll get into this idea of writing GUIs and event-driven programming. Those two things go together. And then again, during final exam week, we'll do another super quiz. I'm calling them. I have no idea where I came up with that phrase. It just kind of came to me. I should copyright it or something. Okay. So first of all, any questions before we fire up here and get going? Okay. Now, this particular exercise I'm going to do for you today, all right, this Python memory layout thing, this is something that I have always in the past done on a whiteboard. we're going to see how this works. And if it doesn't work out so well, then it's not something, you know, I'll put that in my back pocket and say, if we ever have another pandemic, let's not do that. As you can kind of get, you're right. We're in uncharted waters in so many places here that it, you know, it kind of boggles the mind to try to figure out how to do a lot of these things. All right, so I'm setting my screen up. While I'm babbling at you, I'm going to set my screen up so that I can do this. Because what I want to do is I'm going to share my screen and we're going to walk through a little exercise here, okay? All right, we're all set. And if there are no quick, I'm going to do a share screen. I'm going to share my screen. Okay, now, quick question for you. Are we having issues with flickering? Somebody just in the chat, let me know if you're seeing this weird thing where stuff flickers. No, that's good. Okay. Okay. No, and I think I answered the question that this is not on the super quiz. This is hopefully this will help you understand a little better what's going on with object or with tuples and such. Okay, all right, let's start here. So here's what I want to do. I'm going to create a tuple, and I'm going to call this tuple A, right? And it's going to have X. So A is a tuple, and it's got X, Y, and Z in it. Okay, and then B is going to be a list, and it's got 15, 16, and 17.0 in it. And then I'm going to create a list, and I'm going to call that list AB. All right. Now, let's use this function that Python has that tells us where something is stored. So I can say ID of A, right? And A is a tuple, and this is its ID. So I'm going to go over here and I'm going to say, see, this was easier on the whiteboard, but that's okay. We'll make this work. So I'm going to sit here and I'm going to say, this is A, and this is its ID. Okay. And we're gonna call that thing right there A. Right? And what did I put into A? Well, let's see. I put into it, I should be able to put text in that. That is a box. And I can edit the text. And it's going to have a in it. Oh my, all right, I can fix that. See, this is where I thought I was gonna have some issues. There we go. Okay, so why that outside the box? That's what all right, I'm gonna do something different here. I had told you this is something I've done before, but I've always done it on the whiteboard. So we're gonna have a text box. I'm gonna put it up here, and I'm gonna put A in it. And I am going to create a bunch of those so that I can mess with them. All right, so there's A. Now, I put B into another variable, right? And I put B into something here. And then I put C into the third one, right? So let's ask ourselves, where are those located? Well, so X, over here I did A, X, Y, and Z, and over here I did A, B, and C. So there's a question that popped up. You're allowed to store integers and floats in the same list. That's absolutely true. I mean, pretty much anything. Okay, so this is A, right? And it contains X, Y, and Z. Well, let's ask ourselves, where is X? Well, I can't really, I could try this. Let's see. There's where it is. So let's now try this. Let's say A of 0, right? Those are the same location. So here's what we know, right? Right here, I'm going to take this one. I'm going to put it here. And this is element 0, right? And it contains that value. And that's really poorly formatted, but that's okay. I can fix that. Look, there it fits. It's just unreadable. I'll get that. I can change that. Let's, that works. All right, so element 0, right, is this, right? Because the location of X is right here. That's where X is located, is in that location right there. And that is a memory location. So A of 0 is a pointer to X. Now, if I say what's the ID for Y, I'm going to get this one, right? So first I'm going to go over here and I'm going to copy that. I'm going to paste it. I'm going to come over here. I'm going to put this value into it. Okay, and here I'm going to copy this. I'm going to put it right in here. And this then is element 1, right? And it has this same value that was over here. Okay? And so that is, this one here contains the Y. Okay. Now, you can probably guess what's going on here. The third one contains Z. And so let's look at that. Let's do that this way. We'll take, it's the ID of the element there. And if I check this, you'll see that's the same thing, right? So I can take this one. I can put it here. And this here is going to replace that. That means that this one here will now be element 2 of this tuple. And the contents there are going to be what we had over here. Okay, so that's element 2. Okay, so we've created this. Now, let's go back. I created T, right? T contains A and B, right? So what is the ID of T of 0? The ID of T of 0. Well, what's the ID of A? Those are the same thing. So if I come here and I say, well, okay, so this here is T, right? This is my list T, okay? And it has 2 elements. It has an element 0, and its element 0 has a value, and the value that's associated with that is this 479272128. And that ID is A, right? So what we did is we actually just took and we put A, which is this tuple, right? So this is a tuple. Let's put here, this is X, Y, Z, right? That's my tuple A. This here, this is a list, and it has an ID. It has a location in memory, and that's here. So if I take that, I put it here, right? This is my list, 508, 248, 56. That's where it is located in memory. Now, actually, I wanna point something out that's really interesting, and I don't know if you caught this. Notice that these are located in different places in memory. The characters ended up in one place, and the list ended up somewhere kind of different, and there's a reason for that. So the boxes with the elements are 0, 1, and 2, and A. That is correct, right? This is A of 0, A of 1, A of 2, okay? And this is a tuple. And that should be a 2, not an S. Okay, so what's the second thing that's in here? In T, right, the ID of T, where am I typing? The ID of T of 1, the second element is that. That is also the ID of B. So if I'm going to take this, I'm going to copy paste. I'll put this down here, okay? This is B, and B is a list. And B is at 508, 249, 36. And it contains 15, 16, 17.0. And I just got to clean up. There we go. Widen that just a little bit. Okay. It should be no surprise, right, that if I look here, what I'll find is in element 1 of T, element 1 of T contains the address of the list B. So this is actually saying, hey, that's this thing down here. Actually, I want to do this. I want to go here. There we go. There. We can delete that, right? So here's T. T of 1 or T of 0 is A, and T of 1 is B. And that's the actual memory addresses where those are located. So now, if I look at these, I'll take this and I will drag it down here. I'm going to put it here. This is going to contain 15, right? And then this one will be 16. And this one will be 17.0. So 17.0 and then 16. All right, so what's the ID of 15? The ID of 16, the ID of 17.0, right? And then the ID of B of 0, 0, the ID of B of 1, and the ID of B of 2. That's interesting. 17.0 got a different location than what I saw here. So Python's playing some trick somewhere where it did something different. This got a different address than this did. So there are two copies of this floating around in memory. Well, let's go fill these in. So if I take this one, oops, I copied the wrong thing. So there. If I bring this down here, okay, this is element 0, and it's got a larger number associated with it because the integer got put in a different place, very different place in memory. I'm going to have to expand that box a little bit. There we go. Okay, I'll put this one over here. And this is at 888. So that's right next to the other one. And that's element number 1. And then if I take the third one here, this is element 2, and it got an address that's closer to the other things. 521.82736. And these are now pointers to these 3 things. Okay. Now, that's all basically pretty true. All right, save as. I want to save this as demo. I don't want to overwrite the old one. All right, so we've created this structure here. Now, let's talk about what happens if we go and we do something else here. Okay, so we're going to take this one now, and I'm going to do something over here. I'm going to say S equals T. Okay, so I created a new one, and let's call this. We're going to call this one S. Okay. I'm going to say S. All right, so let's look at the ID of S. The ID of S is the same as the ID of T. Take a look at that, all right? You see this over here? The ID of S is the same as the ID of T. They both point to the same thing here. So now, let's say that I do this. I say T dot append, and let's say I'm going to append to T. I don't know, what should we append? Let's see. I'm going to add a Boolean to T. So there's T. All right. So now that is T element 2. T of 2, right? T of 2 is that. What's the ID of T of 2? Okay. So we just added another box on here, right? And this has, the ID of this is 2. Oops, 2 colon, and it's 203.11.208.16. Okay. And that is pointing to down here. True. Okay. Now, I'm actually kind of curious. I don't know if this is going to work. We're going to see. We did get the same value. So and that is located at this same location here. And so now we have a pointer from this one to here. Okay, so if I look at S now, and I look at S of 2, and I look at the ID of S of 2, right? What just happened? Well, that's the thing, is when I did S equals T, I got another pointer to this same list right here. So every time I change this list, S and T both see exactly the same thing, right? All right, so I'm going to do a trick here, and I'm going to paste another copy of this same page in. Now let's go back, and because I'm going to do something a little different. Okay, so let's Let's unwind this change. Okay, so we're back where we were. I have the old one there, so you'll be able to see it. Okay, so I unwound that change. All right, I'm going to save that. Now, let's say I go over here and instead, well, let's do this. Let's del t of 2, just so the t is back where it was. Okay. Now, what if I say this? S equals t dot copy. Now, what is the ID of S? What is the ID of T? These are two different things now. So let's look at what actually just happened when I said S is now a copy of T. So here's, I'm going to actually, I'm going to see if I can do this. Yes, I can. I'm going to move this up and out a little bit. It's going to give me some more flexibility. Okay, so I said S is a copy of T. Well, what actually just happened is, take this, I'm going to do a copy, and I'm going to do paste, and I'm going to move that down here. Okay. For those of you, this is like 7th level PowerPoint wizardry, right? So the ID here for S is 7341520. Okay. Now, let's see. What is S of 0? What is the ID of S of 0? It's 479128. Okay. So this is, I'm going to take this, whoops, take this, I'm going to do a copy, paste. I'm going to pull it down, I'm going to pull it to here, and I'll take this, and move it up just a little bit. Okay. Now then, let's go here. And this is still pointing there. Okay, so ID of S of 1 is still the same as this one. So here's what I'm going to do. I'm going to say, whoop, that's not what I wanted to do. There we go. I'm going to take here, and this is now pointing there. And I'm going to change the color of that so that we can tell it's a different one. And then here, I'm going to come out of here. And I'm going to go there. I'm going to change that one to red as well. Okay. Okay, so you can see now that S and T are two different lists, but they point to the same things, right? Should be able to see that. So the box elements 0, 1, and 2 are all in A. This is the ID in A, 0, 1, 2, where it's located. And then these are the ones that are in B, which was the list. Now, I want to do two things, and I want you to see what happens. So first of all, let's go through the exercise we just did with T. Now I'm going to say T.append true. Okay. There's T. What is T of 2? And what is the ID of T of 2? All right. So I'll come here and to T, I just appended a second element. And that element is element 2, right? And it's located at this address, 203.112.0816. And it contains the value true This contains the value true, and it is at that location that we just talked about, right? It's at 203.112.0816. That's where this is located. And this is a pointer to that true. Now, if I look at T, I see true. If I look at S, I don't. The reason I don't get that when I look at S, that I don't see the true anymore, is that this is a completely different list now. When I added something to T, I didn't add it to S because S is a copy of T. But here's what I want to do. I want to do one more additional thing here to kind of show this to you. Here's what I want to do. Let's take, remember our list B, we had our list B. What if I say B dot append, and I append the number 18 to B? There's B. All right, well, let's look at what that's going to do. I actually want to do this. I want to move this over a little bit to give myself some space. Now I'm going to say here, I'm going to take this, and this is B, remember? This is the list B. And I am going to take that. I'm going to copy that. I'm going to move it over here. I'm going to put the value 18 in it. 18. Okay, so what is my ID of 18? What is my ID of B of, this is 0, 1, 2, 3. Oops. ID of B of 3. Okay, so the ID here is, this is the one that's closest. All right, so this is 3. And the location it's in is 203.133.9920. And it points to that number 18. Okay, it should be obvious now. I hope you're seeing this, right? If I look at S and I look at T, both of them now see that number 18. Do you see that? Right? If I go here, let's draw. Right? Those both get the number 18. And the reason they got the 18, I want to stop doing that. Okay. So the reason they got that number 18 was that the reason they got that number 18 is that when I added this element to B, right? B is actually part, this is B, B is part of both S and T, right? Both S and T point to B, so I can change B. B is mutable, it's a list. So I actually have the ability to go in and change that and add stuff to it like that. And that's what you'll see, is that the list, this list is nested in both of these lists. When I change it, okay, these lists appear to change. Now, what if I go back? Let's go back, and I still have A here, right? And I have this ID for A. What if I go back and I say A equals QRS? Okay, there's A, there's S, there's T. The ID of A, here's what happened. Look at this, the ID for A changed. When I did this, I reassigned A, okay? I did not change this. This list, or this tuple here, named A, that tuple didn't change when I did that. And the reason it didn't change is because it's immutable. It cannot be changed. I created a new thing called A that is out there in memory somewhere. that I can put in another list. But this old one that is inside S and T, it's still out there in memory. Somebody just messaged me, this sounds confusing. It actually is a little confusing. It's why I wanted to go through this, but what I wanted you to see is what's going on under the covers and why. This is the why. This is why when you embed a list inside another list, or even if you embed a list inside a tuple, right? The tuple itself is immutable. However, the contents of it might be mutable. Let me show you an example of that. Okay, so let's say here I have S and I have S and I have T. These are two lists. Okay, and I have B. B is a list. So let's create. I'm going to create another one, which is a list, and it's just got a couple of numbers in it. Okay, and I'm going to create a tuple, and I'm going to call that tuple. But we'll just use A. Okay, and that's this. So A contains two lists. Now, if I do del, okay, B of 2, okay, and I do C dot append 20, okay, there's B and there's C. I just changed those. If I look at A, it looks like the tuple changed. So the question that popped up is, can I differentiate between the two A's? Actually, the difference between the A's is there's an old A and there's a new A. And the list that we created initially has a copy of the old A in it. When we reassigned a value to A, we created a new one, but the old one is still out here. This A, that is this thing right here, is still there. It's not going anywhere because it's inside T and S. They both have copies of it. But if you look at what the exercise I just did here, let me do this from scratch, right? And we'll use completely different letters because the letters could be confusing. So I'm going to create a list, and I'm going to put numbers in one of them, and I'm going to create another list, and I'm going to put letters in the other. Okay, so there's my two lists, and then I'm going to say Q is a tuple that contains those two lists. There's Q, there's M, and there's N. So that's Q. Now, I cannot change Q, okay? There's no way for me to put another list inside Q. However, Q contains a list, contains two of them. So if I say m.append 4, and I say n.append E, right? So there's M and there's N. If I look at Q, I will see that the list's changed. And the reason I see that is if we go back over here, right? It's because the tuple that I've got contains a list inside it, and the list can change. The tuple just knows that it has the list. It doesn't have the elements of the list inside it. Tuples are mutable, are immutable, which means I cannot add anything to the tuple. But if it contains something that's mutable, that thing can be changed. Is that making some sense? The good news with this lecture is, again, and it might help, because what I'm going to do is I will save, right? I'm going to save both of these, and now what I'm going to do actually is I'm going to save this session for this, because now I want to go do something else. I want to shift to another topic. Because I'm going to I'm actually going to close idle, and then I'm going to reopen it because I want to start from scratch. Because now what I want to do, I actually want to do some I/O stuff, maybe a little bit of that. Actually, I have something else I can show you. Let's do this. I am going to share something different because I had another thing queued up that I think would be kind of good. So instead of going to the I/O stuff right away, let's talk about slicing examples. So slicing is something that now we can apply. Did the flickering stop? Because I just moved the windows so they don't overlap. I often found that the flickering was when something like the chat window overlapped. The no as in, oh, it's still there? All right, let's try. Tell me now. If not, I'll just share the whole screen. All right, that's what I'm going to do. I'll just share the whole screen. That will work better. All right. I believe that when I do that, it actually does a better job of avoiding the flickering. I don't know what causes that flickering. I can't find the chat window. It's here somewhere. It's really weird. The chat window disappears on me periodically. There it is. It ended up under everything else. Okay. Are we better with respect to flickering now? Good. Okay. All right. So I wanted to, this is actually something I've got that we can go through a little bit. This is a little bit of review, which will help actually, it's one of the things we could review next week as well. So when we talk about slicing, okay, slicing is applicable to strings, lists, and tuples. Just a second, I gotta mute myself here. Just I wanted to, the answering machine had to pick up, it was a message for my wife. So I didn't want to hang up on it. Okay, so let's talk about slicing. So what I want to do here is just talk about a couple of things with respect to slices. So we talked about how slices, these apply to strings, lists, and tuples, right? They apply to all three. And we've got this idea that we have a start, stop, and a increment, okay? And this will get posted to Moodle, so you can go take a look at it. And this is a good thing to go into idle and play with. Experiment with this yourself and see what you get with it. Because I want to show you here, for instance, these, right? If I say a number colon, I'm basically saying start at this number and go to the end. So starting from element 0, 1, and 2. I can say go up to something. Well, if you remember, the last element we specify is never included. So if I say :0, that is actually going to give me nothing. And the reason is it's telling me go up to the last element or go up to the first element, but that one's not included. Well, obviously, in that case, we will get nothing, right? If I say :1, I'll get the first element only. So that's start and stop, okay? I can include both of them, and I can say, give me a range. And then I can say : 2 or : 3, for instance, will give me every other or every third element. And then I can combine those. Okay, now, the indices, when we start, okay, so that's weird because my screen is reversed. So the indices, when we start on the right, okay, at the end, the ones on the right, we count backwards from -1 to -n. So t of -1 will be the last element in something. And if I want to, I can drop the last element by saying :-1. If I specify from -1 to -3, okay, it's kind of weird because the default is to increment by +1. Okay, so if I try to move from the right to the left, I got to do it backwards because my camera's reversed. If I try to go from the right to the left, I have to specify an increment of going backwards. Otherwise, I won't get anything. Now, I can actually reverse. I can reverse something by using : :-1. I can basically say, go backwards. Okay. I can do all of these same things using strings. All of this stuff applies to strings. It applies to tuples, lists, and strings. Okay. So I will post this. I will post this to Moodle, and you can take a look at it. Okay. All right. See, I want to do. Let's see. I don't know. We could start on I/O, or I could let you go a few minutes early today. I'm trying to decide which way I want to go. I think it's in some ways it's up to you. We're going to be doing review next week. What is Python exceptions? Okay. There is somebody said it's in week 11. There's the Python exceptions thing. That's actually, it's called a Moodle lesson, and it's actually some stuff on exceptions, and it includes a couple of exercises, quiz type things. So it's actually, think of it as being an assignment. It's something you'll go through. You get points for doing it, but it should be kind of low stress, and it'll augment what we do in class with exceptions. All right, I'm going to demonstrate just a little bit of some stuff with I/O. Let me share my screen again. And I'm actually going to show you just a little bit of stuff with I/O. First thing I want to show you is I am on Windows, okay? So Windows and, of course, the Mac and Linux, they behave a little differently. And I want to show you a little trick here. So I'm going to create a file name, okay? And I'm going to say it's an E://, but I'm going to start by doing it this way. E:/users, documents, right? I can do this. You can actually, this makes it a little easier in some ways. You can select stuff, but I can do this. 2020 spring. Nope. I thought it was spring 2020. There we go. And then in here, I created an input file. Input file.txt. Okay, so here I go. I created something with a file name in it. No, I did not. Okay, I wanted you to see this because this is kind of an interesting thing. Python is actually okay with you using forward slashes, even though as you all know, right? The file name separator in Windows is a backslash. However, in a Python string, a backslash represents an escape character. So Python is actually okay with this, and it can handle this. So I can now say open file name read. Okay, type file var. I can look at file var, see what's in it. Okay, this is a variable I created. So I have the ability, I can open files. So file var here is open. I opened this file name and I opened it for read, right? I can say file var2 open, and now, well, let's create an output file, okay? And I'm gonna call this output file 1, okay? Now I can say file var open. Oh, I just overwrote my file name. All right, that's okay, because I already used it. Okay, so now I have, I overwrote my file name twice. I'm not doing so great today. Here's what I'm gonna do. I'm gonna call this the input var. Actually gonna start again. Input name. See, I love that sound. That means I'm losing people. When I hear that, I know that someone just logged off because I was fumbling with the keyboard. It's okay, I totally get it. All right, so there I've got an input. Then I can say I will do an output name, and that will be output file 1, and then output var. Okay, so it's a lot of work there. But what I just did is I opened 2 file variables. Okay. I opened them from 2 different file names. Right? I have 2 different strings, 2 different file names. Over here, I'm going to go ahead and I'm going to open the input file 1. Okay, so here's an input file, right? So there's an input file, and I am going to now read that input file, and I'm going to show you how we can do this. So I can say for line in input var, okay, print line. What I just did is I read that file 1 line at a time, and then I printed it out. Anybody notice anything odd about what got printed out? Anybody see something strange with that? There's 2 carriage return line feeds. Every line got 2 of them. So let's go back and take a look at what might have happened here. So for line in input var, I'm going to try something else. I'm going to say print line, and I'm going to do this. I'm going to drop the last character off the line. That did more than I expected. I got too clever. A equals A It should have dropped the last character. It did not. Okay, well, I got really clever and something strange happened that I didn't expect. So there you go. So let's try this. 4-line in, actually I have this in my notes. I want to do this. But I am probably not going to. We're going to run out of time. And I think what I'm going to do is I'm going to let you go, because what I want to do is I don't want to fumble around with the IO too much. I'd rather be a little more methodical about it, especially since I just did something that made me curious as to why I lost the entire line when I did that. So I think what I'm going to do is I'm going to call it a day here. Okay, so next week, Tuesday, we will review. Okay, and we're going, and then the super quiz thing, kind of the exam replacement, will take place next Thursday. That will be an all-day thing. It'll be at 24 hours, or I will give you an extension if you need it. I know there's a lot of weird circumstances going on for people, and that's something, you know, I really want to be accommodating about. So, you know, what I want to do is Tuesday we'll review. This will cover everything up through sets and dictionaries. Okay, but it won't cover IO, and I'm not going to make you do the memory thing. The memory thing was just so you understood. When will at what US time? I will have the Moodle set up well in the stuff on Moodle set up well in advance. So anybody, because I know that I've got students that are not, they're not even, that I have students I think in China and India. Get in touch with me. Let me know what's a good time to start and stop things, and give it to me in Greenwich Mean Time, because I can convert back and forth between Greenwich Mean Time or Zulu and Eastern Time pretty easily. And we'll figure out what we can do with that. I mean, I might even make it go for more than a day and a half, just so that everybody can do it at a time that's relatively convenient for them. Okay? All right. Any last questions before I let you go? All right. Oh, right. There was this question about that assignment, which is, let me go find that question in the homework. That must be in homework 8. I'm guessing. I haven't looked at the homeworks in a little while. Yes, it's in homework 8. Takes a tuple T and a, okay. So the question was raised. There's a problem there. It says write a function find in tuple that takes a tuple and a key, returns the index of the location in T that has the key. What it's basically telling you to do is find the location, if I give you something, tell me where it is in the tuple. So if I gave you a tuple T that contains 0, 1, 2, 3, 4, and I said find 3, it should return the index where 3 is located in the tuple. That's all it is. So it's a function that searches a tuple for something. Does that help a little bit? By the way, there's an easier way than searching. Just want to tell you. The index is the first location at which you can find it. You don't have to look for more than one. It's just the first location that it's at. Okay. Now, it should not throw an error or do anything like that if it's not present. Okay. Because the reason I'm telling you that is that there is a function for tuples that will do this. However, if what you're looking for is not found, that function will throw an error. So you shouldn't throw an error. You should do something graceful in that case. Okay? All righty, I am going to stop the recording, and I will see you all in a very virtual sense next Tuesday. Okay, be safe, be well. And if anything, again, if you're struggling in some way, please let me or someone know. I mean, we're all kind of in a very unusual situation. Okay. All right. Take care. If you have any other questions, and there was a question that just popped up to me, go ahead and email me that question. How do we study for the super quiz? So imagine the super quiz as, and we'll talk about this more Tuesday, but it's going to look a lot like the VPL assignments you've had and the homework assignments you've had. It's going to look much like those, not so much like the first exam that we had. All right, I'll talk to y'all. I'll see you in a virtual sense Tuesday.